All right, guys, so we are live. Thank you, everybody, for coming today. My name is Monica Rojas. I'm the Member Engagement Specialist at South Florida Tech. As most of you probably know, we have officially rebranded to a regional organization. We're a nonprofit. We are based in Palm Beach, but we do have people all across the three main counties, and we really focus on building our South Florida Tech community. And we do so by providing events and hosting workshops to develop our local talent, as well as provide networking opportunities, branding opportunities, and kind of just, making everybody realize that South Florida is more than just beaches and palm trees. It's a community full of diverse people with so much talent, so much passion, and are contributing towards our tech community. So if you guys have any questions, please check out our new website, southfloridatech.com, or send me an email at Monica at southfloridatech.com. So now I'm going to hand it over to Todd. He's the lead instructor and founder of Boca Code, and he's going to be leading our workshop today. Go ahead, Todd.
Thank you so much. Good morning, everyone. Let me just, okay, great. So you guys should be seeing my title slide now, I hope. Please, feel free to interrupt me. Feel free to ask questions in the chat during this talk. I appreciate you guys all being here early on a Friday morning. You guys know what you're here for. We're talking about data analytics. We're talking about Python, little machine learning. My name is Todd Albert. I'm the founder and lead instructor at Boca Code. And I just wanted to thank South Florida Tech as well for hosting this event. And my email, I put it in the chat for those of you that are on Zoom. And also it's right here, todd@bocacode.com. So feel free to reach out. And I know a lot of you already know me, but some of you might not know some of these things about me in terms of data analytics. So I've been programming since 1982, and I've actually been doing data analytics professionally since 1995. So while I was in college, I was hired by one of my professors to analyze data for research that he was working on. Back then I was using Excel to do it, primarily using Excel. But over the last 25 years, my skill set in that area has grown, and I've used it for my research as a professor and NASA fellow. And in fact, the seminal paper that I wrote that I had published was on classifying images, satellite images, like you're seeing here on the right, to determine what is ice and what's not. So we can actually look at an ice cap like the Calcaya ice cap here in Peru, and actually monitor changes over time. So this shows 20 years of ice loss on the Calcaya ice cap. And actually, to this day, I am still considered the steward of the Calcaya ice cap. So if you look up Calcaya, you'll most likely find my name attached to it. So what I want to talk to you about today, though, is I want to go over some, just some basics of data analytics. I want to talk a little bit about Jupyter Notebook and some of the tools that are available to us in Python that are really powerful and surprisingly easy to use. And then we're going to go through a demo and actually look at some data and and do some actual data analytics. Using a little bit of machine learning and some linear regression. So for those of you who are very new to data analytics and are just kind of here, like, what is this all about? I want to talk about why study data analytics. In marketing and in design jobs, the ones that are requiring data analytics skills have risen over 50% since 2013. It is becoming the most coveted skill in marketing and in business in general, right? Being able to actually, I've worked with a lot of entrepreneurs over the years who are just, they just go with their gut. They're like, oh, well, I think we need to do this. I think we need to do that. And usually being the senior developer, I have to tell them, I have to steer them and try and get them to not respond so quickly, but to actually look at the data and what's the data that supports these ideas that you have. And within data analytics, Python is becoming the tool of choice. In fact, just in general, the use of Python it's the fastest growing language there is. Now, for the last 7 years, JavaScript has dominated. JavaScript has been the most popular language for the last 7 years, but Python is growing so fast that it's actually forecast to overtake JavaScript, potentially by the end of this year in terms of popularity. It's incredibly popular because it's so powerful and relative to other languages. It's very easy to use and to learn. All right, so let's jump right into data analytics. So data analytics is this process of discovering useful information that can help inform conclusions and support decision making, right? So that's kind of the formal definition of it, right? You look at the data and you actually pull information, useful information out of that data that can help you, make business decisions, right? Or other decisions, right? As you're going to see, you could even things like when an email comes into your mailbox, there's data analytics that decides which way to route, is that spam or is it good, right? That's using data analytics and machine learning. So how do we look at the data? Well, you can break it down into nine types of algorithms. And, of course, just before we get into these, then, sometimes this gets a little overwhelming. People are like, oh my God, there's 9 classes of algorithms. And, within that, there's a ton of different specific algorithms. How do you know what to use? And, so we're going to simplify that a little bit and kind of steer you towards what's the right algorithm for the question you're asking. But sometimes it's just, it's about the data that you have or the question you're asking. So the first type, which, was kind of similar to what I did with the ICE, is what's called classification, where you're just trying to look at a member. In the case of a satellite image, it's 1 pixel in the satellite image, or maybe in a customer database, it's just a customer, like literally a member of your, of your database or your application or whatever. So it's the probability of a member belonging to a specific class, right? So maybe if you're an e-commerce site, you're wondering like, is this customer likely to buy again, right? This one-time customer, do they belong to this class of repeat buyers? Or if you're a streaming service like Netflix, you're like, is this a type of person that's likely to cancel, right? So it's the probability of a member belonging to a specific class. The second type is regression. So with regression, you're not looking at a class like, does the person fit into one of these buckets, but you're actually trying to predict a value. Like, how much is this customer likely to spend over the next year, right? So you're trying to do value estimation. Then there's similarity matching, right? You're trying to identify which members are similar, right? So maybe you've identified, maybe you're South Florida Tech and you're like, wow, we have these certain members that are really active and they give a lot of their time and everything. How do we target other people like that in the community? How can we find similar people to that? There's clustering. So clustering is similar to classification, but usually you don't know what those classes are. So you're looking for natural groups. Like, can we take our members at South Florida Tech and break them down into natural groups and see what kind of clusters form naturally based on the actual data? So these are very different because one, you're defining the classes ahead of time, typically, and in the other, you're looking to see, are there classes, right? The fifth type is called co-occurrence grouping. And you guys see this all the time with, when you're shopping online and it's like, you go to shop for this mug and they're like, hey, people who bought this mug also bought this pen, so you see this all the time. But imagine if you owned like a grocery store, right? And you always put the chips next to the beer because you figure, hey, people who buy beer, they're likely to buy chips. But when you look at the data, peanut butter and jelly, right? When you look at the data, you actually see that people who buy beer are more likely to buy hot dogs. So maybe you realize like, hey, let's rearrange the store, move the chips to the next aisle and move the hot dogs and hamburgers over to this aisle or something, something like that. So this is an example of like analyzing the data and then applying the insights that you gain to to make an actual business decision. Profiling. Profiling is a way of characterizing behavior. And every one of you is very thankful for this because your credit card companies have built up a profile on your behavior, which might sound creepy, but what happens is as soon as you deviate from that behavior, they flag the charge, right? Ooh, this looks like it could be fraud, right? They have profiles built of what fraud looks like. What are fraudulent type charges? So if somebody gets a hold of your credit card and starts charging it, they will characterize that. And you're going to see when we start talking about machine learning, yeah, not only is is this data there, but then if you see a charge that doesn't belong on your credit card statement and you call them and you say, hey, this charge is fraud, that gets now added to the model and the model gets rebuilt. And now they have a better data set for determining what is fraud. And so that's part of the whole learning aspect of machine learning. There's link prediction, which you guys are also familiar with because you see this on your social networks, right? It's trying to predict, Allie, you're friends with Todd and Monica, and Michelle is friends with Todd and Monica. So Allie and Michelle, maybe you guys should be friends, right? It's trying to predict these connections. And then there's data reduction, which is the 8th type. And in data reduction, when you have a really large set of data, you sometimes try and say, whittle it down to what are the most important pieces or the principal components of this. So one of the most common, I like that, Allie's like, let's be friends, Michelle. One of the most common types of data reduction is called a principal component analysis, where you're really trying to get at those, those key properties. And this can be really important. Like in remote sensing, we sometimes have just massive amounts of data, like layer upon layer upon layer, and we try and narrow that down to just the layers that we need. And then finally, the 9th type of algorithm is something called causal modeling. And for those of you who've done any statistics, you know that just because two things appear related, they're not necessarily, that doesn't imply cause, right? I was at a convention once doing, on data analysis, and one of the members presented something where it was like this 30-year history of the number of Republican versus Democrats in the Senate and the membership of this data analytics committee over time, and they matched up like perfectly. So, he drew from that, as long as, if we have more people in the data analytics community, then we have more, I forget what it was, Democrats, let's say, in the Senate. And, he assumed cause from that. And obviously those two things are completely unrelated. It was just by dumb luck that they matched up. And so the causal modeling is actually trying to determine what's causing the relationships in these data. And I keep mentioning machine learning. Machine learning is the relationship between data analytics and machine learning is very gray. There's a lot of overlap. Machine learning is actually a subset of artificial intelligence. The first uses of it were for OCR, or optical character recognition, where you would, let's say, scan in a document and the computer would actually try and turn those pixels into actual letters and text. And that's come a long way now. You can just take a picture with your phone of something and have it read it and even translate it into another language for you. It's pretty impressive. Your spam filters, your fraud detection, those are also examples of this, and something that I've done a fair amount of, which is computer vision as well. So the tools that we're going to be using kind of fall into the machine learning category. So, another way of looking at machine learning just in a really simple way is basically you start out with a set of data and you train a model, you train some kind of algorithm or model with this data, and then you apply that data to that model to other data. And then, you can test and see your results and see what you get, and then use that to improve upon the model. And this kind of iterates through this process of training, applying and improving upon your model. You know, like I said, like a spam filter, right? Every time you mark an email as spam or go into your spam mailbox and say, wait, this isn't spam, and you know, this is a false positive, then you're helping train that model that's used to flag things as spam. Now you might not see that immediately because these models are so well trained already that by flagging one email as spam, the next time you get an email like that, it might not notice that it's spam. It's went back in the early days of these, we would see that more immediate result. Nowadays, these models are so well developed that it's hard to influence them. But this is the idea of learning. I sort of alluded to the fact that with classification, you're defining your classes ahead of time, and with clustering, you're not. And what we call that in data analytics is supervised versus unsupervised. So basically, supervised is where we already have the classes determined. So any type of algorithm, we could use it in, well, not any, but a lot of our algorithms, those 9 algorithms we went through, you can use them in supervised ways where you're saying, hey, these are the classes, right? I have buyers and non-buyers, right? Those are predetermined, right? Versus letting the computer decide what your classes are, letting the data and some algorithm help you split up into different classes. So like I mentioned, like if South Florida Tech wanted to dump their members into a database and say, hey, look for similarities, look for clusters, and tell me, you know, do we have different types of members, right? Maybe we want to redo our membership levels, right? You know, I'm not suggesting you guys do this. I'm just saying, you know, as an example. And so you see these natural clusters of memberships. And so then you look at those groups in detail and see what the differences are between them, and realize like, hey, we have these 4 different classes of people that we're serving, right? And it's not, you know, it's not necessarily broken down by race, age, ethnicity. It could be by, you know, how active they are in their group, what services they're using, things like that. So you can break into these groups that you can't otherwise see because your data has so many different dimensions to it. So letting the computer, which can see things in, you know, many more dimensions than we can, try and break down those classes. Okay, so where do we start, right? What's the process when we go, you know, so all right, you guys probably have this sense that you have some big data set or small data set, whatever it may be, and you have a question you want to answer, and you're going to analyze, you're going to apply some algorithm to it and try and learn something from it. So what does this process look like? Okay, and this is the process that's now the industry standard, which is why it's actually called the cross-industry standard process for data mining, or CRISP DM. Some people just call it CRISP, some call it CRISP DM. And here's what it looks like. And this looks very complicated, but it's not all that complicated. Basically, you start here with some, can you guys see my mouse? I'm like circling my mouse on, but okay, good. So you start with some business understanding, right? Where you think you know something about your data, or you have a question about your data, and then you look at the data and you go to this data understanding step, which is where you're trying to figure out what are the strengths and weaknesses of my data, right? What data do I have? What data am I missing? And as you look at your data, it might give you a better understanding of your business. And that's why we have this arrow back here, because as you're looking at your data, you know, and you can imagine like, you know, a group of business people sitting around a conference room, you know, saying, hey, we have this question. Okay, well, what data do we have? All right, this is the data we have. Oh, well, we can ask these other questions based on that data. So it can influence your business understanding, which influences your understanding of the data. So you get these little loops here. But once you feel like you understand the data you have, then you want to prepare it for actual analysis. And very often your data is in, you know, 10 different databases or 10 different places. Oh, we got to get our email list from here, and our customer list from here, and our product list from here, and our membership list, and all of this. And so you have to bring in all of this data from all these different places, and they're all in different formats. and getting them all into this one unified format and all joined together so that you can use it, that can be a large part of your project. Once you have it prepared, then you can start modeling. And we'll talk in a minute about what this means. But as you start to model, it'll start to bring out information about the data that might make you want to pull in more data or let go of this data or change which data you're using. So that's why you get this little side loop here. Then you model your data. And once you have a model that is maybe, going towards answering that question that you had. So you had a question, you grab the data, you prepare it, you start to analyze and model it. And then after you have a model, you look at that model and you look at it, is this model working? What is it telling us? Things like that, which maybe it's not working, or it's not working well. So you go back to the modeling stage and then you try something else and then you evaluate that. And so you get this little loop here. Once you have a working model, it is hopefully answering some questions about your business, which can then come back and help inform you and give you better understanding of your business, which could then start you on this whole loop again. You say, oh, we weren't asking the right question. Let's look at this instead. So then you go through this whole loop again. And so the idea is this is an iterative process by rule, not by exception. So if you feel like you go through this and you're like, holy crap, we're back at the drawing board, you're not. You now have a deeper understanding. And so this is an informed loop, right? You're gaining insight into this. And as you gain insight, you're going to ask better questions. You're going to develop better models. And eventually you come up with some model that you're like, this is it. This is the model that we're going to use to make our business decisions. And that's when you deploy. And this could be like, oh, we're deploying our new spam filter, or it could be, oh, we decided we're going to move, the beer next to the chips or whatever, but now you actually take some action based on that. So let's just go through quickly each step again. There's the business understanding, which is understanding the problem, helps you ask the right questions. Better understanding leads to better analysis, right? Like which customers are likely to cancel their subscription. Then there's the data understanding, knowing the strengths and limitations of the data. And we can have a feedback loop where as we get new data, like in the case of a spam filter or fraud, it continually feeds back into and improving the model. Data preparation, this is the least sexy of all the steps, but data are very seldom in the format we need. The exercise we're going to go through today, the data are nice and clean and exactly as we want them, already prepped for you, so we don't have to do the boring part. But in reality, this can be up to 70 to 80% of a project. In some cases, you could spend most of your time just gathering the data and getting it in the right format. Then there's the sexy part. There's the modeling, right? Where you're actually trying to build a model or pattern that captures your regularities of your data, right? And a model is basically a simplified representation of reality, right? It can be mathematical, it could be logical, it could be some kind of hybrid. And a lot of people, they talk about, oh, the hurricane models don't know what the hell they're doing, and it's hard when you have a very specific event like a single storm. Something that's much easier to model is climate, right? As much as that might seem unintuitive, but if you think about it, like if you're a school teacher and you're going to give 100 students the same exam, you probably have an idea of what the grade distribution might be like, right? Do you know exactly how Susie is going to answer number 12? No, you have no idea. That's hard. Those specifics are hard, but the overall patterns are easy. You're going to have 24 A's and 37 B's and whatever the distribution is, that is easier. So the idea of like getting the overall pattern is much easier than a very specific, minute to minute forecast. So and so when we want to model something, whether it's, how much money a customer is going to spend, or whether it's, modeling, which way a hurricane is going to turn, you're basically, creating a simplified representation of reality. You're simplifying all the physical, there's so many things happening with physics and everything in the atmosphere, or with decisions that people are making, but you're just looking at a simplified set of data and trying to come up with a reality from that. So now once we create a model, we want to test it. We want to validate it. We want to see how reliable it is, right? And the way to do that is to take your model that you built with this data and now apply it to other data, right? So oftentimes what we do is what's called a train test split, where you have this much data, you take, say, 80% of it, and you use this to train the data. And you ignore this. You put this basically like in a lockbox. It's put away. Nobody touches it. Nobody looks at it. And you train your model with this data, and then you look at this data and you see, how does the model predict this data? And so that's called a train test split. That's when you take your full data set and typically depending on how big your data set is, if you have a really massive data set, you might only need 1%. But for a smaller data set, it's maybe 20-30% that you're going to look at for training. And then you're going to measure things like, for every point that it's predicting, how far off did it get from the actual value, right? So if your actual value is here and it predicts it here, there's a distance there, and you can take that distance and you can measure that over every single point and create an overall measurement of your model. And one of many, many ways that we do this is by using the root mean square error, which is, here's the formula for it. It's, the square root of the mean square error, but basically you sum up all of those differences, you square that over the number in the data set, and then you take the square root. You don't need to memorize these formulas because they're all built into the software you use, right? Like in Excel, you would just type RMSE or RMSD, root mean squared deviation, instead of error. So the idea is, like, if you have a model, which is the gray line, and then you have your actual values, which are these circles, you measure those distances from the circle to the actual versus the predicted. And then you take those differences, you square them, you take the sum of those divided by the number, and you take the square root of it. That's, it's just one measure of error. There's a lot, just giving you a sample. And then deployment, again, is when you act on the model or you apply it into the real world. All right, so I better speed up. Jupyter Notebook. All right, so we got through basics of data analytics. It's the quick and dirty, 30-minute version of what data analytics is. Now I want to talk about Jupyter Notebook. You're going to see it in about 2 minutes, but I just want to say Jupyter Notebook is, and there's other notebooks, but Jupyter is my favorite. It's a way to write and test code and notes in a presentation style worksheet, right? It's amazing because the code is written in cells, which are almost like Excel formula. So for somebody who's not a programmer, it's super easy, super approachable. For somebody who's like, a marketing person that's just trying to add data analytics, this is a very, it's very approachable. But even for a coder, it's amazing because you can write up what you're doing, write the code, see the results, the graphs, the charts and everything. And then you have this presentation that you can give that's in this beautiful format. And as you're presenting it, you're presenting it to your company saying, hey, these are what the data are. This is what they say. You can actually, if they're like, well, what if you change that? What if you change that? You can actually go in, change it, run it, and see your graphs change and everything change live right there in your presentation. So it's really amazing. And, but it's Python. It's, you have regular Python code. So it's really useful to have everything in one place. You have the code and the output and your notes and everything all in one place. And if you change your code, you see the updates. So we're going to jump into Jupyter Notebook in a second here, but I want to just briefly go over some of the Python libraries that we use, because Python on its own, it's really powerful, but we have these data analytics libraries that we use that make it so much more powerful and so much easier to do a lot of very, very complex things. So let's talk about some of these. So NumPy or NumPy, So you hear it pronounced both ways. NumPy it adds support for large multidimensional arrays and matrices to Python. And it also adds high-level mathematical functions like linear algebra and matrix algebra into Python. So NumPy is like one of the first libraries we always import when we're looking at big data, because we're going to use it to handle these large data sets. And then there's pandas, which adds this data table structure. It adds operations for manipulating large tables in time series. And one thing that's great about Panda is it has one line code snippets where you can read in an Excel spreadsheet, a CSV file, HTML, like you name it, like pretty much you could scrape a web page and it'll pull in data from every table on that website. It's really incredible. So I use pandas a lot. There's an alternative to pandas called koalas, right? I don't really use it as much. I mainly focus on pandas. Then there's Plotly, which helps you just very like one-liners to plot really great graphs. And then Plotly is kind of like the base, just kind of like NumPy is a base, and then a lot of these other libraries build on top of it. Plotly is this base that a lot of other data visualization libraries build on. So like matplotlib, which is the most popular one. And I just want to jump out and show you this website for matplotlib. It's kind of a boring website, but if you go to the examples here, you can see this is the table of contents of this page here, right? So we're at lines, bars, and markers right here is the top, right? And you can see all of these categories, right? Like our favorite recipes, right? And so if you see, you know, and just looking at the scroll bar here, I don't know if you guys can see this, but there's just, you know, a million different types of plots. So if you're looking for a specific type of graph, you can come here, you know, see what, you know, what this graph is, and, you know, say, oh yeah, I need to know how to position my title, or, you know, whatever it is, whatever you're looking for. Oh, I need a scatter plot on a polar axis, and you click and you get, you know, here's all of the code to do that, and different examples and different ways of doing it with the exact code snippets that you need. So very, very powerful. And then built on matplotlib is my favorite library, which is Seaborn. And Seaborn it takes matplotlib to the next level. It's more advanced. It adds more statistical libraries and visualization tools, and it adds these beautiful default styles to all of your plots. So even if you're not using Seaborn, you could still import it, and it makes all of your plots look better. And just a, you know, quick jump over to their website, go to their gallery, same thing, and you could see just how, you know, how gorgeous these plots are. You know, these heat maps and, you know, violin plots, and, you know, just incredible stuff. And usually, you know, a lot of these, you know, they show you this whole code snippet here, but a lot of these can be done in one line of code. So they're really, really incredible. And then finally, the last one I want to talk about is scikit-learn, which it always bothers me to hear this name out loud, scikit. It just sounds ugly. Scikit, like scientific kit, learn for machine learning. It's a machine learning package, and it's a algorithm library and machine learning package for Python. Really powerful, really popular. So we're going to be using a lot of these today, doing a quick demo. And, you know, but before we get in, it's, you know, as I mentioned, there's so many different algorithms, and data analytics can get a little overwhelming. So, you know, it's like, oh, which algorithm do you use? And there's some flowcharts out there, some that are really complex. Scikit-learn has this great cheat sheet. If you type up scikit-learn algorithm cheat sheet, you'll get this incredible detailed one. It's really a lot prettier than mine. But this is meant to just be like a great simplification of that, right? Are you looking at data categories like buyer versus non-buyer? If yes, okay, is it labeled like supervised? Yes, okay, it's classification. No, it's not labeled, it's clustering. No, we're not looking at categories, we're looking at quantities. Okay, then you go to regression. No, we're not looking at quantities, then dimension reduction. So, you know, just a very simplified version of this. So today what we're going to be looking at is some sample e-commerce data, and we're going to be looking at quantities. What we're going to try and do is predict how much our customers are likely to spend. So that would be not a category, but a quantity, and that would be regression, right? So we're going to do just a very simple linear regression in um, in Jupyter Notebook. So this is Jupyter Notebook, and I've already created these cells that have my write-up, right, which you can go back and add later, but this is like documentation. So the first thing we're going to do is, and due to time, because we don't have a lot of time here, I'm just going to copy and paste some of this stuff just to make it a little simpler. But I'll type this last one. So basically what we're importing NumPy, right? And usually we refer to NumPy in code as NP, pandas as PD, matplotlib, we're importing their pyplot library as PLT for plot. And then we're going to import my favorite, which is Seaborn, if I could spell. And we're going to import this as, for some reason, everybody imports this as SNS. That's just the standard. You can import it as you could call it anything you want, but typically it's done as SNS. And if I hit enter, it just takes me to a next line in this cell. But if I hit shift enter, it actually runs that. And this little star here says, hey, we're running. This is running. And then 1 says, okay, this cell was run first. So you can run things in this. I could jump down and run this line here next if I wanted to, and this would get it too. So you can actually see the trace of what was run when. Okay, so Fioraldo just asked if this is in GitHub. What I'll do is once it's done, Fioraldo, I can upload this to GitHub, and as well as the data set, so you guys can play around with it and see this. I don't have it in GitHub to follow along right now, but that's a good point. So okay, so the next step is to read in our data. So now I got my libraries, I'm ready to go. Now I have to pull in my data set. So I'm going to use, remember, I'm going to use pandas for that, which we imported as PD. So I'm going to say PD read. And if I hit tab here, it's going to autofill all of the show me all the possible autofills in Panda for read. And you could see I could read in data from the clipboard, CSV, Excel, HTML, JSON, Pickle, SPSS, SQL table, SQL query, whatever the heck I want, right? I'm just going to import a CSV file. And then I know my CSV file is in users. This is one of my old Nebular computers that I'm on right now. It's in downloads, and I'm just hitting tab to autocomplete. And then I have it as e-commerce customers.csv, and I hit shift enter, and it just read in that data. And it outputted it because I didn't save this data to anything, right? What I actually meant to do was I meant to assign this data that gets read in, which is a data table like you can see here. I meant to call that like customers, CUST, right? Or data, or whatever I want to call this. So I'm going to read in the file, and I'm going to assign that to a name, a variable, a memory space. So let's run that again. So you could see now this went to 3. And now I have this in this data table in memory, not listed out in my notebook. I didn't want that. We can look at the first few rows if we want, by saying, show me the head, the top of this data table, and this will return the first 5 rows, right? And you could see, let me just zoom in a little bit more here, make it a little easier to read. I see Monica's like, this gives us the person's email, their address, but what I'm really interested in are the numerical fields here, right? Average session length, time on the app, time on the website, and then length of membership in years, and then how much they spend a year on average. So this is what I'm trying to predict, right? How much they're going to spend in a given year using these other values, right? And I can also get summary statistics for this, just saying, using pandas, just saying, taking my data table, whatever I called it, which in this case I called it data, and say .describe. And now what it does is it ignores all of these text fields like email. You can't get a mean of email, right? But it automatically looks at all of the numeric fields and gives me the count, the mean, the standard deviation, the min and max, and then my quartiles. So for a normally distributed, where those standard deviations are basically. Excuse me. So now I've got my data. I've got some understanding of my data, right? So now to understand it a little deeper, we might want to use some exploratory data analysis, right? So we can actually, do things like, well, let's look in my data, let's specify a specific field in my data, like the, if I could spell, yearly amount spent, right? I want to take this column, the yearly amount spent, and I want to create a histogram. And you guys see, this is like freaking Excel formulas, right? Right? Like, even if you've never programmed before, but you've done Excel, right? Which, a lot of like marketing people have, at least can write an Excel formula. This isn't much more complicated than an Excel formula. And now I've got a histogram of how much people spend. So you can see, most people are spending between, say, $400 and $600 a year, right? Right around 500 is the mean. And I can even, if I want to add more bins to this, I can pass in bins, and let's say, I want to show 20 bins, and I run that again, and now I've got 20 bins. So this is the, one of the beauties of this notebook is I've got, I can even now say, let's add another column, right? Let's convert this to text and say, notice above that, most people spend between 400 to 600 with av around 500, right? And now I just made that note in this notebook, right? And it's not code, it's just actually like text on that notebook. But I would, to really understand my data, I would want to do a histogram of every one of the numeric values, right? And I might want to look at scatter plots of each numeric value, of certain numeric values versus yearly amount spent to see if I see any relationships. And Seaborn has a, Seaborn, SNS. I still don't know why we call Seaborn SNS. Seaborn has this function called pair plot, where you just send it your data, and depending on how much data you take, you see the star there, it's working. It takes a minute. For really big data sets, this could take a couple minutes. But what does it do? It gives you, let me zoom out a little bit so we can see a little better. It gives you a histogram of every numeric field. So here's average session length histogram, time on app histogram. So the diagonal are the histograms of each one of the fields. And then what it's doing is it's creating, and the above the diagonal or below the diagonal, it's symmetric. So, and you can actually do things like different above and below, but I just want to keep things simpler. So here you see average session length versus time on app. And this is the scatter plot of that. And if you know anything about statistics, you don't see any real relationship here, right? We can just focus in on this last row here, which is the yearly amount spent, what we're trying to predict. And you can see average session length, maybe there's a little relationship there. Time on app, yeah, there seems like there's some relationship there. Time on website, not much. But length of membership, strong correlation, right, from what we can see. So we might put that in the notes. Oh, thanks, Michelle. So we might put in the notes, that length of membership appears to be the most highly correlated, right? So, all right. So now we're pretty comfortable. We've got, it seems like we have a pretty good linear linear relationship here. In fact, we can use Seaborn to actually plot a linear model, LM plot, and we could pass it what we want for the X, which is, let's say, that length of membership. And we can pass it what we want on the Y, right, which is what we're trying to predict, which is the yearly amount spent, and pass in our data, which is data. And now we get this nice Seaborn regression model of one versus the other, which we can, look at what the coefficients are and our R-squareds and all that stuff. But I got to finish up really quickly. You got to get to the juicy parts since we're running low on time here. But all of these things point to me that a linear model is probably will probably suffice. So we've made the decision. We're going to go with the linear model. So let's define what we're trying to predict, which is our yearly amount spent, right? So we're going to define that as Y. And then in X, which we use a capital X, we're gonna define all of our feature sets that we want to use to predict yearly amount spent, which I conveniently put right there for us. So we could just paste that in. So this is we're pasting in an array of just the column names of the columns we're going to use to try and predict yearly amount spent. So we just do it like that. And now we want to use, we want to remember, we want to split off we want to section off some of our data for testing. So we're going to train and then test. So we're going to do a train test split. And scikit-learn has this great tool that'll do that for us. So we're going to actually pull in from scikit-learn, which is sklearn. We're going to pull in from their model selection library. We're going to pull in train test split. And then from their linear model library, we're going to pull in linear regression. So now we have these two. And for those of you who aren't programmers, right, these are things you look up. You're like, how do I do it? You don't memorize this stuff. You look these things up and then you import them and then you can use them. All right, so what we need to do, we need to split our data up, all right? So we're gonna use train test split to say, okay, we have now X and Y, right, which we defined here, right? And then we wanna tell it what our test size is. So let's say we wanna preserve 20% of our data, right? 20% of our data for testing, okay? And crap, that shouldn't be an equal sign there. We're gonna take our data, we're gonna split it. Oh, sorry, let me zoom in a little more. We're gonna take our data and we're gonna split the X and split the Y into a training set and a test set. And we're gonna use 20% of the data for testing, randomly selected. So what this is gonna output is it's gonna actually output 4 variables for us. It's gonna output our X training set, our X test set, our Y training set, and our Y test set. So we get all 4 of those from this one line of code, right? So now we have our test data, X test and Y test, and our training data, X train and Y train. And now we're gonna just create a linear model. We'll call it LM. And we're gonna use that linear regression that we imported from scikit-learn. And this just says create a model. We're not training it yet, just create a linear model. And then we're gonna train it. So we're gonna say LM, and we use the function fit to train our model. So what do we pass in here? We pass in our X train and Y train data. So we're saying, hey, we have all this data to predict this Y. So, take these X training values and try and predict these Y training values from them. And we do it and it says, okay, cool, we got a linear regression that fast, right? So great, how do we look at the model? Well, one thing we can do is we can print out LM from our linear model, we can print out the coefficients like this. And what this literally says is actually, let's print out, let's also print out our X columns, just so we can see right here. So the coefficient for average session length is 25, for time on app is 38, time on website 0.47, and length of membership 61.67. We'll get into what those mean in a second, but I want to just, basically what this is saying is that for every year of membership that you increase, with all other things being held equal, for every year of membership, you're going to spend, $62 more. Members are likely to spend $62 more. So does this model fit? How well does it fit? Well, let's look. Let's now use our linear model to predict from X test, right? And remember here, when we said fit, we gave it the X train and the Y train. This time we don't want to give it Y test, right? We don't want to say here Y test. We don't want the model to look at that. We just want it to look at the features and see if it can predict Y test, or how accurately it can predict Y test. So let's call this Y predict, right? And run that. And the best way to now look at that is to do a scatter plot of our predicted versus our actual values. So we're just going to use a regular plot function, a scatter plot, and we'll pass in Y test versus Y predict. And if our model is perfect, we would get a perfect straight line. And this is pretty damn good, right? Well, how good is it, right? So these are the actual values here versus the predicted values. And I can actually label that. I could say plt dot X label is actual, and then I could say plot Y label is predicted. And now I have those labels there. So how good is our model? Well, we can import from sklearn. There's this library called metrics, and we can use metrics to get the mean squared error of our test versus our predicted. And then we can use numpy to take the square root of that, and that gets us the root mean squared error, right, which is 9. And what does that mean? Well, the bigger the distance, it's in dollars, right? So we're basically, in a nutshell, we're saying, the mean average error here is $9. I could predict within $9 how much a customer is likely to spend. And it's kind of a simplification of it, but that's one way to look at it. And we can actually look and make sure that our residuals are normally distributed using a Seaborn distribution plot. And we can do our Y test minus our Y predicted, and see the distribution here. And we can see, yeah, roughly these are normally distributed, centered right around 0. So we feel like our model is pretty solid, right? And it's 11 o'clock, so I just want to finish up real quick and say, from this, if we look at our coefficients, and here's a nice way of looking at our coefficients in a little table here, right? I created a Panda data frame of our coefficients and the column names. So we can see that, length of membership has the strongest influence, then time on app, and then average session length, where time on website has almost no influence. So now we have to draw conclusions from that. So we could say, does this mean that we focus all of our money on, steering people towards the app because that has the highest influence? Or do we say, holy crap, our website sucks. We have a terrible website experience. Let's put all of our resources towards making our website experience as good as our mobile. So, again, like sometimes this can create more questions than it answers. But, there's the quick and dirty. data analytics, Python, Jupyter Notebook for you. Actually, sorry, I meant to show one last thing. Two last things. I wanted to say thank you, and please visit our website, bocacode.com. If you want to learn more, you could take our we have a weekend crash course on this, where we're going to basically be doing this for an entire weekend, looking at data, different analytics methods, and so forth, in great depth, in October. So check us out, and let me know, as always. Let me know if you have questions in the comments, or just come off mute and ask them.
Yeah,
Thanks
no,
so
thanks
much.
for that, Todd.
Sorry, it was kind of harried. I wanted to get through the whole demo and the whole talk, and it's a little tight.
No, yeah. So if anyone has any questions, just please take yourself off mute, or like Todd said, go ahead and write in the chat. I know Allie and I had a few questions. Allie, do you want to share the questions that you had first?
Yeah, there was a couple questions that came through the private chat. The first one was, do you have to have a strong statistics background to be successful in data analytics, or same thing with a computing background?
The answer is the answers to both of those are no. They can certainly help. Having an understanding, a basic understanding of statistics, like having at least taken a basic stats course, would certainly be useful, so you can kind of understand what these what the coefficients are and what a root mean square error is. So but you learn that in like week one of a stats course. So that's useful. My stats is not strong, and and basically a lot of people who go into data analytics, they either lean heavily on the stats or they lean heavily on other mathematical methods. So I've always kind of leaned towards other methods, not the stats so much. Personally, you don't need a strong computing background. You definitely need to know, like, be able to work your way around, say, Excel, to as I think hopefully you got a quick glimpse that using these like Jupyter notebooks, it's not that much trickier than using Excel. So and Python really is one of the simplest languages to learn. There's so much there, and I know I whizzed through, but all of the functions I was using, those aren't typically things you memorize. Most of them, they're the ones you use in coding. This is like the deepest, darkest secret in coding, is the stuff you use every day you memorize, right? You stop using it, you forget it, right? And you have to look it up again. And that's the same thing. If I don't touch Python, or I don't touch data analytics for a few months, I'm back like, wait, how do I do this again? And that's normal. That is 100% normal, even for the most senior developers. So I went through this talk several times to know all of these things, and I had notes right next to me. You guys probably saw me looking at my second screen, like, okay, what am I doing next? I wasn't even looking at this notebook. I was looking at the completed one, so I can try and mimic it, just to also to speed things along. But yeah, I mean, so much. And a lot of times, here we were starting from scratch, right? We started from the very beginning, but oftentimes, you're taking a notebook like this and you're saying, okay, now I want to import this other data set, right? So you just change the one line where we imported the data, and then maybe you got to change a couple of names down below, and now you have a linear model already built. So you now can take this linear model and apply it to other things, right?
Yeah, I know I'll feel that way Googling like everything when I get back to school.
Mm-hmm.
But the last question that I got was, this was data analytics with Python. What are some other compatible languages?
Yeah, so depending on the circles that you're in academic settings, they use SPSS a lot. SPSS can be a little expensive. So there's an open source package called R that a lot of people use as well. So I would say that those three are the top three. And they're, my uncle does data analytics, but he's on the academic side, and he tells me, oh, nobody uses Python. Everybody uses everybody uses SPSS. But in the tech world, when you research data analytics, everyone's like, it's like Python's number one, R is number two, and SPSS is like down here. You know, but in this other world, SPSS is here, R is here, and Python's here. So it just really depends on what, you know, where you're coming from.
Awesome. Monica, that was it for my end.
Thanks, Sally. Todd, actually, are you going to send over the few links with all the resources that you provided for the follow-up email? Just because I was not able.
I'll have to send those to you after, and maybe you can because I don't have it up in GitHub right now. So I'll right now they only live on my desktop. So
okay. Yeah. No. Does anyone else have any questions?
I just, you know, my admissions director, Jen Nelson's on this call, and she's telling me to mention the course again. So, you know, don't forget that we do have a full data analytics course, like A to Z in October 10th and 11th. It's over a weekend full time that Michelle's already registered for. And we've got a few people taking that course. So it's filling up. So if you want to get in. And we also offer we just announced a scholarship for women in tech called Her Future Reimagined Scholarship. So definitely take advantage of that. We have all kinds of financing options available. And, you know, the course just is not an expensive course to, you know, add this like really critical skill to your resume.
Awesome. All right. Well, thanks, Todd. I will mention that in the follow-up email as well, October 10th, right?
Awesome. Yeah, 10th and 11th, that weekend.
All right. Well, thanks everybody for joining us today, and hopefully we'll see you guys next week. And I hope everybody has an amazing and dry weekend.
Thanks,
Bye,
Monica.
everybody.
Thanks, Sally. Thanks, everybody.
Have a great one.